you are assigning 0. Okay, that is repeated for n times. Okay, now if you see this properly, when this function is called, for this function we need to pass two arguments. One is a pointer and second argument is n. And to pass the control to this function, the processor has to set the what is called as context saving operation. That means before passing the control to function, it's supposed to save the context of the main function, then it has to save the return address, plus then it has to transfer the control. So in this transfer of control, certain overhead is there. So CPU has to spend some time to transfer the control. However, this transfer of the control is required only when value of n is not equal to 0. When the value of n is not equal to 0 means we do not want to clear any memory location. So we do not expect the memclr function to be executed. So this is not known to the compiler. What I mean to say, there are certain limitations of the compilers are there. So there is a limitation of the compiler in generating the machine codes. There is a limitation of the compiler in knowing the values. There is a limitation by the compiler in at what time which function to be executed. So all these limitations can be solved by handwritten code. What I mean to say is, in this example, if value of n is equal to 0, it's not required to pass the control to this function. Other than we can avoid
Sir, the slide is in slide 15.
Come again?
The PPT is showing slide 15 only.
Then why? Now can you see slide 60 now?
Yes, sir.
Yeah. Okay. What these cases indicate is, see, I told while generating the optimized code, the role of compilers is very crucial. I mean to say, there are certain cases in which even compiler cannot help us in generating the optimized code. And one of the case is the value of n is equal to 0 for a function memclr in this case, that you are passing a one pointer called character data, and n is a second argument. And what we are basically doing is wanted to clear a couple of memory locations pointed by the pointer, and number of locations to be cleared is indicated by the value of n. Okay. Now to pass the control to this function to clear the memory locations, and we know that there is a function called latency will be there. Yes or no? So this function called latency can be avoided by avoiding the passing control to this function, provided value of n is equal to 0. So however, even the value of n is equal to 0, since compiler is not aware of what is the value that n is taking, it has to generate the function statements for all possible cases. Okay, it will adds up what is called as the function called overhead. So that can be avoided. Okay, this is one case where compiler have no answer. So there is one more case is there, and the case 2, in that if you notice that same function only, memclear. So if you see, for the each iteration of the for loop inside this function, you are clearing one memory location. Okay. Yes, can you see that?
Yes, sir.
Yeah, now tell me what can be done if the pointer that is pointed by the first argument of this function is 4-byte aligned. You understand? You understand my question, right? If the pointer that we are passing to this function is a 4-byte aligned, what can be done?
N minus.
So that n minus 4, and instead of clearing a one memory location at a time, we can clear 4 memory locations, so that it's possible to reduce the number of iterations of the loop. Okay, you know that when the number of iterations of the loop are reduced, the loop overhead will be reduced. So that's way we can optimize the code. Even the compiler is not having answer for this question, this particular scenario. There's one more case is there. So if the n is multiple of 4, it's not required to iterate for every iteration of the loop. Rather, we can perform operation of clearing the 4 locations simultaneously, or else clearing the 8 locations in one iteration of the loop. Yes, if I'm writing a program statement inside the body of the loop to clear the 8 memory locations, then rather than decrementing n by 1 for every iteration, we can decrement by 8, so that we can reduce the loop overhead by a factor of 8. That's the meaning of it. So these things will not known to the compiler. It is the job of the programmer to take care of these things and get the optimized code. That means we need to analyze Later, if any cases which are shown in these slides are there in our application code, later we need to optimize to take care of these conditions. Okay. So finally, as a concluding remarks, to write efficient C code, we must aware of limits of specific C compiler. So I have shown the couple of limits. I have two more limits are there, and limits of the processor architecture the compiler is mapping to. What I mean to say is, we should know the features of the compiler that is converting high-level language to machine codes. Thus, we should be aware of the processor features. Okay, say for example, in the ARM architecture, there is one instruction called MLA. It stands for multiply and accumulate operation. In the C program, if I'm writing a for loop to perform multiply and accumulate, okay, so many cases it will not make use of the MLA instruction that way is there in the ARM architecture, because MLA does multiply and accumulation one clock cycle, so that execution speed will be improved. Rather, making use of one clock cycle, it might make use of multiple clock cycles, okay, because it is not generating multiply and accumulate operation. So that's the limitation of the compiler. We should be aware of the limitation of the compiler. It is converting the machine codes. Okay. Now, as an example of ARM C compilers, I'm showing there is one compiler called ARM C compiler that is there in the tail. There is one more genome C compiler that is there in LBC Expresso design suite. Okay, in the lab for that VLSI guys, we made use of ARM C compiler that is there in the tail. Okay. Similarly, couple of other compilers. So all these compilers are there for ARM CPUs only. But remember, each compiler has its own capabilities. So if your objective is to get the optimized code, you should be aware of limitations of these compilers. Okay. Now, two more cases are there. Please go through this. This is one interesting case is there. I will consider this. So I'm in slide number 21. Can you see?
Yes, sir.
Yeah. What I'm trying to say is, there is one instruction in the ARM architecture that is called mul, stands for multiplication. RD, RM, RS. Operation is RD is equal to RM into RS. So it will multiply RS and RM, and result is stored in RD. Okay. If you look at how it is multiplying by considering some examples for RM and RS, I've taken RM is equal to 18, RS is equal to -1. Okay, RM is equal to 18. It stores in the 32-bit register. It stores in 32-bit register. Okay, you can see since it is storing as a 32-bit number, you can see many leading zeros are there. So many leading zeros. Similarly, RS is holding -1, whose complement of -1 is all ones for 32 bits of RS register. Now, if you take RM is equal to 18 and RS is equal to -1, as per the binary multiplication, it takes a 17 clock cycle. That means this mul instruction takes a 17 clock cycle because it does multiplication bit by bit. But if compared to other case, if I take RS is equal to 18 and RM is equal to -1, so we're swapping the operands of, swapping the contents of RS and RM, rather than taking RM is equal to 18 and RS is equal to -1, but taking RS is equal to 18 and RM is equal to -1, we can see the operation is RD is equal to RM into RS. So it takes only 4 clock cycles. Why this takes only 4 clock cycles? Because we are multiplying same set of numbers. Only thing is registers which are used to take these two numbers are varied. Okay, so in the ARM architecture, there is one special feature called early termination of the multiplication. So what it does is, if the no more leading zeros are there, multiplication will terminate early, because multiplying any digit with 0 will give 0. Okay, is it clear? Okay, so multiplication will terminate early. That is possible only if RS is having 18 and RM is having -1. That means if RS is holding a number, it is having many leading zeros, then multiplication will terminate early. So this is feature available in ARM architecture. This is a limit of the compiler. So what I mean to say is, if compiler reports RM is equal to 18 and RS is equal to -1, then early termination of the multiplication will not work. Okay. Now, to optimize the code, first thing you are supposed to do is analyzing the software. Okay. Now I taken an example. Example is one function with a name called total. Total is the name of the function. For that, you are passing an array, int array, and you are passing second argument n that indicates the number of elements of this array. If you look at the program statement inside this function, what you are basically doing is, it's an accumulation operation. That means there is an integer variable called sum. So all the elements of the array are added up with a sum. Okay, this simple accumulation operation. Now we'll try to analyze the complexity of this software. Okay, so please try to understand, when I say complexity, our intention is to analyze the time complexity only, right? Okay, now for analysis, I name the different lines of this program segment. Okay, all different lines of the program segment are numbered. You can see 1 to 8. And now we'll start analyzing. Okay, so for analysis, we need to consider line by line. Okay, guys, can you see I'm in slide number 23?
Yes, sir.
If you see the line number 1, so line number 1, see there are two arguments you're passing for this function. You know that arguments of the function will be saved on the stack. Yes or no? So since we are passing two arguments, so it has to save two arguments on the stack. So there will be two push operations, and these two push operations happens only once. That's because function is, these two push operations will execute once for every call. So there are two operations. These operations will happen once. And line number 3, if you consider, so line number 3 is this: int sum equals 0. Okay, it has one assignment operation. Even this happens once, so there is only one operation. On line number 4, there is one more declaration statement is there, that is int I is equal to 0. So even this operation happens once, so one operation. Whereas consider line number 5. So if you see line number 5 has one initialization statement I is equal to 0. This happens once, and I less than n, this comparison happens n times, and I plus plus increment will happens n times. Okay, so line number 5, totally 3 operations. The first operation happens once, second operation happens n times, and third operation happens n times. The total number of operations will be 2n, that is n plus 1, that is 2n plus 1. Okay, that is a, so these are the number of operations that will happen in line number 5. Okay, the line number 6, if you notice, the line number 6, there is a one index operation is there, and there is addition operation is there, and an assignment operation is there. So these 3 operations will happen. Number of iterations of loop, if I say number of iterations is equal to n, then total number of operations line number 6 is 3 into n. Okay, 3 into n. Okay, and the last is a return statement. The return sum, even this happens only once. Okay, that is after completion of the for loop, return sum is executed. So the line number 7, this operation happens once. So one operation. So all put together, if you add, totally you will get 5n plus 6. 5n plus 6, these are the number of operations that will happen in this given program segment. Yes or no? Are you able to understand this?
Yes, sir.
Now if I take how much time all these operations will take, what we need to do is, then we need to multiply number of operations by time taken by that particular operation. For example, in the first case, line number 1, there are 2 push operations are there. So 2 operations, if you multiply by number of amount of time it takes to perform those 2 operations, then we'll get the time. Similarly, second operation that happens once, if you multiply that by time, then we'll get the time it takes to perform that operation. Similarly, if you know about the time different operations are taking, then to get the time total program segment is taking to execute is obtained by multiplying total number of operations by time. Okay, is that clear? Yeah. Yes, can you see I'm in slide number 24?
Yes, sir.
Now you see, to understand this, I have taken certain values for n. For n is equal to 10, okay, so our number of operations for the given program segment is 5n plus 6. For n is equal to 10, it gives 56 steps. So no, for n is equal to 100, it gives 506 steps. Similarly, for n is equal to 1000, it gives 5006 steps. Okay. Now we can see as n increases, significance of 6 in this expression it reduces. Yes or no? So if you notice that as n increases, significance of 6 in this expression reduces. So it's possible to drop the 6. We can only say the function f of n is proportional to phi of n, and this proportion is a linear proportion. We can notice that because f of n, that is the number of operations this function is taking is a linear proportion of n. N is a number of elements or of the array what we are passing for this function. Okay, right? Is it clear?
Yes, sir.
Is it clear why I adopted 6?
Yes, sir.
Similarly, if you notice this expression, I told it as n grows, as n increases, the significance of 6 in this expression decreases. Similarly, if you notice this expression, can you drop the 5 also that is there for multiplying with n? Can you drop 5? Even value of 5 what is shown as a coefficient of n is inaccurate. Can you tell me why it is inaccurate? Yes? So we are dropping 6, constant 6, that is because a significance of 6 reduces as n grows. Similarly, I can drop 5 also. Tell me why? Why I need to drop 5? I mean, showing n 5 as a coefficient of n in this expression is inaccurate. That is because, see, to arrive at 5, what was the consideration is, see, time taken for each operation is 1 cycle. So in the previous example, previous analysis, please notice properly. Okay, the different machines will take a different time to execute same operation. So that is 5 is came, that is because we assumed that each operation is taking 1 clock cycle. Since the different machines are taking different clock cycles, what we can notice is even it's possible to drop the 5. So in order to indicate the time complexity, there is a one term called as asymptotic complexity, that means approximation. So I can say the time complexity of the given program segment is asymptotically varying with n in the linear sense. Yes, sir, that's the meaning of that. So bound on the number of operations grows asymptotically like n. That means as n grows, okay, the time complexity of the given function varies in the linear sense. Okay, finally, to represent the time complexity, what we'll do is, there is a one big O notation is there. Please try to understand. Let me type that. So there is a one big O notation. Big O in the sense capital O. Big O notation. What it says is, so for given function, I can say the time complexity is O of n. That's the meaning of big O. So what it says is the complexity of given function varying in the linear sense with respect to number of elements of the array. Is it clear? Is it clear?
Yes, sir.
Yeah, in the given program segment or given program, there will be some statements whose execution is repeated over certain iterations based on the some value, like n in the previous place, or there might be some other statements we will execute only once. Yes or no? So those execution time is not depending on the value of n that indicate the data. So those type of statements are called constant time statement. For example, in the previous example, there was a int sum equals 0. One statement was there. That's a constant time expression, constant time statement. Why? Because the execution time of that particular expression will not change with the number of iterations of the loop. N is the data number of elements that are passing to that array, that function. So the complexity of that particular statement will not vary with n. That's the meaning of it. I've given a couple of examples for constant time statements. In x comma y, irrespective of number of times the function is executing, these statements will take some amount of time. An assignment x operation is there, x equals 5 into y plus 4 into 5. Even this will take a same amount of time if you are not executing any loop. So these are constant time express statements. Okay, similarly, there are some other constant time statements are there. So looping constructs. Now, if we consider a loop here, I am in side number 29. So we have a loop. So in sum is equal to 0 for j is equal to j less than j plus plus. Can you tell me what is the time how to analyze the time complexity of this program segment? Yes. Can anybody tell? Can anybody tell? See, the first statement int sum what is there is a constant time statement. It takes a constant time. Look at the second for loop. The for loop, the initialization statement will take is a one time it will execute, so it's a constant time. Whereas this comparison, what is a j less than n, that will execute n times, and j plus plus, that increment will happen n times, and later as a body of the loop, this sum plus j, the plus will happens n times, and assignment will happen n times. So if you analyze this complexity of this function, you can see, right? So what is that? What is that? So this is a constant time operation. This is the one operation, execute once. This will execute 10 times. This will execute 10 times. Okay, this is 2n. So this is 1, and this is 2n plus 1, and this is 2n. Yes, and if all put together, it is a 4n plus 1. We can drop 1 and we can drop 4. So what is left with? Complexity of this function varies in the linear sense with respect to n, capital N, where capital N indicates the number of elements. That's what is it. So the complexity of this function varies with n, where n is the number of elements of the array. Is that clear? Is it clear, guys?
Yes, sir.
Okay. So similarly, there are some other examples are there. So now tell me, what is this? Is a constant time expression or what? Bool done equal to? Is it constant time statement or what?
No, sir. We got it.
It's a constant time statement. Why? Because it will execute only once, no? This will execute once, this will execute once, this statement will execute once, whereas the statement inside the for loop are not constant statements. These are not constant time statements. Why? Because these statements will execute as long as done equals 0. As long as done is equal to, this statement will execute. If you look at that, in the worst case, this for loop will execute n times. I mean, this while loop will execute n times. Okay, so the statements which comes under the while loop are not constant time statements. All other statements are most of the cases constant time statements only. Now can you analyze the complexity of this code? Slide number 32. What's the complexity of this code?
O of n. O of n, sir.
O of n or O of n square? Look at that. There is a program statement here. So the first two statements, what are there? Int j comma k comma sum equals 0. These are constant time. Why? Because they will execute only once. If you look at the second for loop, okay, there is one for j for loop is there. J equals 0, j less than j plus plus. Inside the for loop, there is one more for loop is there. For k equals 0, k less than and k plus plus. So the nesting of loops is there. Okay, then sum plus k into j. If you look at the total number of times the sum plus k into j will execute is n square, no? Because for every iteration of the outer loop j, the inner loop k will execute n times. So total number of iterations of the statement sum plus equals k into j is n square. So this is n square, whereas there's one more for loop is there. So complexity of the second for loop is n. So if you add the total time complexity, that is given by n square plus n, always we are supposed to consider the higher order term. So complexity of the given algorithm or given program segment is O of n square. That means this function complexity varies in the square sense, not a linear sense. Okay? Are you able to understand?
Sir, n square plus n is equal to 2n square, right, sir?
N square plus n is equal to 2n square ಅಂತ ಯಾರು ಹೇಳಿದ್ದು ನಿನಗೆ?
Sir,
n square plus n is equal to 2n square.
Sir,
n square plus n square ಅಲ್ಲ ಇರೋದು, n square plus n ಅಲ್ವಾ ಇರೋದು, ಸರಿಯಾಗಿ ನೋಡು. n square plus n. So now say while specifying the complexity of this, what we will consider? We have to consider higher order terms only, right? Yes or no?
yes, sir.
So n square is there. Certain part of the program is varying in the square sense, and remaining part of the code is varying in the linear sense. How the complex? To say how complex my code is, which one I will consider? Linear sense or square sense?
Square.
Square, no. I should consider higher order terms. And what's the meaning of that is, say value of n is equal to 100 you take. Linear sense, number of operations it does is 100 ಬರುತ್ತೆ. Square sense ಆದರೆ n square 100 into 100 10,000 per number of operations it is doing it 10,000. So I need to consider I need to say the complexity of this particular algorithm is varying in the square sense by considering the higher order terms only. Okay. Here complexity ಏನು ಬರುತ್ತಪ್ಪ? What's the complexity of the following code? Can analyze?
n log n.
N log n ಬರುತ್ತಾ? I don't know this. You have to analyze. N log n ಬರುತ್ತೇನಾ?
Sir, bubble salt ಇದೆ ತರ.
Bubble sort ಇದೆ ತರ ಇದೆಯಾ? This part of the code is n only. What about this part of the code? N multiplied by log n, or it's n log n, or more than that? Bubble sort for every iteration of the j, you can see k will iterate j times. K will iterate j times. I think it is there here. It's not there here. You please analyze this. So similarly, the conditional statements. See, please try to understand whether the conditional or unconditional, whatever it is. If some statements are repeating inside the loop, they are not a constant time statements. In that case, we need to consider number of times that loop is repeating. Apart from that, any other statement that will come inside the program, they are considered as a constant time statements. That means they will execute only once. The impact of those statements on the complexity can be dropped. Okay, so the function call is there. I think you can analyze. I will skip this. You can analyze this. Linear search. So what questions are expected from unit 4 is, say, from the topics what to discussion you had. Please prepare for some basic questions like what are the advantages of high-level languages compared to assembly codes, or what are the advantages of assembly codes compared to high-level languages, and what is the difference between native compilers and cross compilers, and different tools of IDEs, and later what else you can get. Plus, in the complexity analysis, you are supposed to prepare for standard searching and sorting algorithms. Standard searching algorithms are linear search and the binary search, and standard sorting algorithms are quicksort and selection sort. For these, you have to prepare for complexity analysis. Okay. So, can you analyze somebody? Can tell me what's the complexity of this? Analyze it quickly.
n.
N. That's because again size is there. No, size is the array. Size number of elements of the array we're passing. Okay, we can say this. Line number 2 is the constant time statement, execute only once. Line number 3 is the constant time statement. Line number 4, if you consider I is equal to 0, execute once. I less than size. In the worst case, execute size times, and I plus plus will execute size times in the worst case. So inside the for loop, if you consider there is one assignment and indexing statement is there. If a of I equals x, the comparison will execute n times in the worst case, and indexing will execute n times in the size times in the worst case, and got it I will execute size times in the worst case. So total complexity of this algorithm, if you consider, it varies in the linear sense with respect to size. Size is the number of elements we are passing. Okay, that's what is there. So this should not be n, this should be size. Okay, the size indicates number of elements of the number of elements in which we are